Kaggle is a platform for data scientists and data science competitions. Ben Hamner is the CTO of Kaggle. Ben, welcome to Software Engineering Daily.
Thank you. It's great to be here.
What is Kaggle?
Kaggle originally started off as a site to host machine learning competitions, where we take interesting data sets from around the world, from companies, from nonprofits, etc. Like, here's the data sets of all the flights in the US in this 6-month period for a problem that we worked on with GM predicting flight arrival time. Or here's 100,000 images of eyes, some of which have a disease called diabetic retinopathy. So we take those problems like that have a really well-defined quantitative challenge that you can grade on it, and then we put those out to our community and say, find the best way of doing this automatically that you can. So challenge our community to develop machine learning algorithms and methodologies that will get the top performance in solving these problems. And we have a community of about 350,000 data scientists and machine learning engineers and statisticians from all around the world that really actively engages with and tackles these challenges.
So who posts the competitions?
It's really a diverse mix, ranging from large companies such as General Electric or Walmart or Facebook to research organizations and nonprofits like the California Healthcare Foundation, to individual researchers, to startups.
And how much do companies pay to get their questions posted?
Typical prize money is on the order of $25,000 to $100,000, with some of the biggest competitions that we've had have had prize money of $500,000 and up.
Wow. Okay. And does Kaggle work with the companies to help figure out what exactly the questions they should ask or what types of data they should post?
Absolutely. Some companies come to us with a really well-defined problem that they've come to themselves, and we work more or less as a platform for posting in that case. Others come to us with a challenge that says, this is the rough idea of what we want to tackle. We think machine learning and you can help in some way. How do we move forward from here? And we'll work with them to identify their appropriate data sets and how to structure the competition and all the details that go into place for that.
What was the first competition on Kaggle?
Let's see. The very, very first competition was around predicting World Cup outcomes. So it was not necessarily the standard competition that Kaggle's become around supervised machine learning ones. So that was more of a toy getting started competition.
Could you walk me through the experience of a data scientist competing on Kaggle?
When they first sign in and go to our homepage and to log up for a Kaggle account, they'll see a list of competitions in different categories: featured competitions that companies are sponsoring, research competitions, and so on. They'll click on one of those competitions and they'll immediately be immersed in a summary of the problem and learn about what the problem they could tackle is. So one of the ones on the site right now with a company called Springleaf is around predicting customer responses to direct mail campaigns. So they'll read a summary of the problem, then they'll be able to dive in to the data set, click data, download the data set, and then on their local machines, they can load the data up into whatever environment they love, whether it's Microsoft Excel to get started, RStudio, Python notebooks, etc. And then analyze the data set, train machine learning models, and create a submission file and make predictions with the machine learning submissions. Then they take that prediction file and submit it to our site where we score how they're doing. And then we immediately put that up on a real-time leaderboard. So they get immediate feedback based on how they're doing relative to all the other data scientists in our community that are participating in the challenge.
So these Kaggle competitions consistently beat the results of academics and industry experts who solve these problems, using their own private algorithms. So what is it that makes Kaggle competitors consistently beat these experts?
The competition dynamic itself is really effective at getting the best possible results, because by putting up a real-time leaderboard and showing where you stand with everyone else in the world that's working on the same problem, instead of just taking the first shot at it or taking a shot at making a couple small improvements and then calling it quits, the people who do really well iterate hundreds and hundreds or thousands and thousands of times over their methodology. They're running an enormous number of experiments, and they're really optimizing and fine-tuning their approaches in a way that they wouldn't be doing without that. So it really encourages a very diverse exploration of all the possible approaches that they could be applying to the problem to tackle it, as well as fine-tuning the approaches that work really well to be optimized for the specific data set and problem at hand.
Interesting. Is this like the type of field where it really helps to actually come from outside the field rather than be somebody that's firmly entrenched in it? Like maybe somebody who's looking at an oil and gas problem might focus on a very narrow set of data, and then somebody that's coming from totally outside the field might have unusual insights?
We see that domain expertise and domain knowledge is really crucial in figuring out how to set up and structure the problem and to figure out what questions to ask and what to optimize for. So all that gets incorporated and encapsulated by saying what data sets should you be using, or what data should you be incorporating on, and what should you be optimizing, and how should you be measuring the effectiveness of that. Then once you've incorporated that and had a well-defined problem on that, then the underlying domain becomes much less relevant. Occasionally people who are domain experts will win a competition. For example, one of the competitions on computer vision that we've run with detecting galaxy ellipticities, some astronomers and physicists were the winners for that competition. But once you have that general structure, the specific domains no longer matter. And instead, the people who win tend to be those that are really creative and innovative in their approaches, and also iterate very quickly and focus on how many questions can they ask and how many different paths they can explore, and really optimize the speed at which they iterate, as opposed to kind of going off, working on a whiteboard for 2 or 3 months, coming up with a couple ideas or kind of a perfect conceptualized model, then implementing that and trying that. Whenever we hear someone taking that latter approach, it always fails and never works out.
How does the experience of an individual competitor on Kaggle compare to the experience of data science teams that work together to solve Kaggle problems?
That's a really interesting question. So a lot of the competitions now are actually run by teams, not individuals. Then really teams have a very diverse array of approaches. On some teams, it's effectively functions as a group of individuals who combine their results at the very end and ensemble their results at the very end, so they're not working terribly collaboratively throughout the competition. And there's other teams that will work very much as a coherent team, and one person will be responsible for the supervised machine learning approach and algorithms. Another person will be responsible for extracting this type of features from the data set. Another person will be responsible for the cross-validation methodology and the approach there. And they'll really collaborate very closely on the end-to-end data pipeline for the competition and structure for that. And one of the new products that we're building out is actually targeted to really help with teams of data scientists collaborating more effectively by sharing the underlying code and sharing the underlying data in a reproducible environment.
That sounds like a product that would be useful to people that are not even on Kaggle.
Absolutely. We have a really strong community, and we see it as a great test bed for evaluating and releasing new products.
So can you talk more about that product? Like what goes into making a product that helps data science teams collaborate?
The first steps of this product you can see under Kaggle Scripts if you go to kaggle.com/scripts. And what that is right now is a product where if you drop into any Kaggle competition, or almost any Kaggle competition, you can go to have a new option that says new script. And you can write a script on Kaggle in R or Python or Julia and other languages that have the data sets preloaded into the environment, as well as having all the libraries that people normally use for visualization, for exploratory analytics, and machine learning available to work with. And then when a user runs a script on our system, it's automatically published immediately to the broad community. So what that's had an effect of doing is has had a tremendous impact on helping data scientists get started on competitions. And we'll see it many people write, here's how to use XGBoost on this competition. Here's how to use Lasagna, a deep learning library on this competition. Here's how to use Neon, another deep learning library on this competition, and so on. Then the advantage that's from collaboration that really helps with that is data scientists can come in and click fork and immediately drop into the same environment that their script was originally written in. So you don't have to work through Python version hell and spend 10 hours making sure you have the exact right set of Python libraries installed and use the exact same version of Python and so on to get their script working. it's something that works immediately and you can start building on top of.
So we spoke to the founder of YHat, which is a company that helps engineering teams and data science teams work together. Have you found that data scientists and engineers that are working off of similar models often have problems collaborating?
Absolutely. So software engineering is 3 decades ahead of data science in terms of collaboration on the great ecosystem of tools that supports that. Software engineers tend to follow great coding standards. They use version control tools like Git or Mercurial constantly. They have great processes around integration testing and automated testing and all the pieces that go into place for that. There's not the same set of tools supporting data science work right now. If you talk to most data scientists today, they're working independently on their own machine. They're not saving code in version systems. No one's reviewing the actual code that they're producing, and it really decreases the confidence in the results for individual data scientists, as well as hurts team productivity for larger data scientist teams.
What are the biggest pain points, like specific pain points for interacting, intercommunication between data scientists and engineers?
One of the biggest pain points that we've come across is going from an ad hoc model or exploratory model to a production system. So the transition from the exploratory work that a data scientist is doing, or a model that the data scientist is training locally, to a model that runs in a production system.
Yeah, so
usually the engineering infrastructure is, especially for larger companies, is very locked down in terms of the libraries and the tool chains that can be used, and those are different from the tool chains that the data scientists use.
Yes, so to give this a concrete example, the founder of YHat that I talked to described a situation where a data scientist, I think, had written a model in Python, and it was like 100, I think he said it was 120 pages, like printed out in a PDF, and he had to translate it from Python to Java or something like that. And so it was the idea that, like, the data scientist made his model in one thing, and you've got to import it into the production system. Does that articulate what you're referring to?
Yes, that's a great example of that.
Okay, interesting.
So that's one of the main pain points between the kind of data scientist and software engineering divide. There's also many pain points looking at data science teams directly. One of them is that if you look at the actual work that data science teams do, in many cases, you'll see that if you have a team of 10 data scientists, they need to do a very similar set of pre-processing operations on the data and transformations on the data, but they're then using that to ask different questions. And if you have 10 data scientists, you'll have 10 approaches to effectively solving the same problem. So in many cases, they're not sharing code effectively, and there's not a good system in place to capture all the analytics work that's being done because it's only being serialized back to different folders on their machine.
It's a nightmare. What's the solution to that?
We believe the solution to that is building out a software product that makes it really easy for data scientists to get a lot of the productivity gains that software engineers have gotten from tools like code version control and reproducible computational environments and things along those lines, but having that operate under the covers and behind the scenes for many newer data scientists, so they don't have to learn all the complexities of Git in order to use that effectively. So switch from the default of nothing's being captured and saved and shared to everything's being captured and saved and shared.
What are the data science concepts that every data scientist needs to know?
Let's see. That's a really interesting question because if you ask 100 people what data science means, you'll get 100 different answers. And so many people have bastardized the term now to be applied to what's used to be called business intelligence or various aspects along those lines where things like coding skills weren't a prerequisite for and effectively get a nice salary bump by remarketing themselves as a data scientist. But some of the competencies I consider absolutely core is data scientists should be able to write code effectively, which includes SQL queries as well as one or more production-oriented languages such as Python or C# or Java or Scala, etc. Secondly, they should be very proficient in exploratory data analysis and visualization. All the effective data scientists I know can visualize things like the back of their hand, are very fluent in what the necessary libraries, whether it's Tableau or ggplot2 and R or other mechanisms. Thirdly, they should have a good conceptual understanding of statistics, as well as intuition around when to apply what statistical tests and how to go down that track. And then finally, they should be able to train and work with machine learning models, as well as interpret the results and figure out what the underlying drivers of those models are.
How would you define machine learning?
One of the ways I look at it is a compiler for data, where you have a system that instead of taking in code and compiling that to make a result, it takes in data, then it learns from the data, underlying concepts, and then it uses that to create an automated system. So that an automated system can be used to recommend movies, to place ads, to rank search queries, or enormous diverse array of different applications.
Do you have a general workflow for approaching a machine learning problem?
Absolutely. So the steps that go into that are, first, understanding what the overall goal is, whether it's a business goal such as increase revenue by X, decrease the speed of the system by Y, increase the click-through rate of this by Z. If it's a research goal such as hit human performance on this problem that doctors are currently using to diagnose diseases, or things along those lines, starting off from what the goal of the problem that you're trying to solve is. Secondly, connecting that back to the data sources that are available or potentially available, and really deeply understanding those data sources, kind of the ins and outs of the problems that emerge and the M&A inconsistencies in them. Thirdly, coming up with an approach to identify how good you're doing on the problem and evaluation metric for that, as well as a training and test or evaluation strategy for how you're going to evaluate your performance. And then finally, going through the feature extraction, feature selection, machine learning model training, and model selection steps to optimize the performance of that. And then if it's appropriate to put in a production system, putting that in a production system, which then falls into a separate set of processes to optimize that online.
Interesting. So you are the CTO of Kaggle. Tell me about Kaggle's tech stack.
I was surprised there's a lot of other Bay Area companies, but we're actually built on top of C# and .NET and the Microsoft Azure platform for our main backend infrastructure that runs the Kaggle.com site itself. And then for the reproducible analytics and software platform that we're building up, we use a mix of both .NET and the Microsoft stack of technologies, as well as Docker and Linux and Python.
Are there any frictions that come from being partly on the Microsoft stack and partly on Linux?
Not that we've hit so far, because Microsoft's Azure platform supports Linux equally as well with Windows, and then those are carved out as separate services.
I don't know if you've used other cloud hosting providers, but I'm curious how Azure compares to AWS or DigitalOcean or whatever other services you've used.
I've not used with any of those other ones closely, so I can't comment on that. But our use of Azure has been phenomenal so far, and it's hit our use case very nicely.
Fascinating. Are there any killer features from it that you didn't anticipate?
Let's see. So over the past 4 years, that platform's evolved very rapidly. Some of the things that have made our work far easier is being able to do things like scale up and scale down database instances with the click of a button. All the work that Azure's been doing Microsoft's been doing in the Azure web world as well, that makes it really simple and frictionless to deploy new web apps and to go from the time coding a feature to having a feature running in production as quickly and as frictionlessly as possible.
Yeah, I've seen a kind of a race, or I don't know if it's a race, but I've seen these different machine learning products that have come out of Azure and come out of Amazon, and I don't have enough experience with machine learning to evaluate them. I did talk to somebody earlier this week who said he uses Amazon's machine learning platform. How useful are these hosted machine learning platforms where it sort of takes away some of the nitty-gritty code aspects?
The approach that they've taken so far, that for Azure, for Amazon, et cetera, they've seen is it's more directly targeted at solving the problem. It's hard to take a machine learning model and put it in production. So for a small set of use cases, they'll provide a machine learning model that runs in production very nicely and effectively. However, where all those platforms really break down is if you have a complex data pipeline that's feeding into it, or if you're trying to do a lot of exploratory work, or if you really want to understand what's driving the model performance or things like that, it's really not targeted to those types of operations whatsoever. And then the way that we view the world is there's two types of data scientists, types A and B, where type A data scientists are, their ultimate product is they're generating insights based on data, where they're using the underlying data to learn more about the world, and then they're communicating those insights back in a way that improves a research goal or a business goal, such as improving how our product's being created, improving how our business is being run, or things along those lines. And then there's type C data scientists who their main output is a production machine learning model. And that machine learning model is running in production to answer queries in real time, such as rank these search results, or what product should I be buying when I look at the system on Amazon, or is this email a spam or not? So the Amazon and Azure machine learning products that they've created so far are primarily targeted at the type B world, and they're very ineffective at the type A world.
But are they effective at the type B world?
I've not used any of them directly, and that's for that use case, so I can't comment on that.
Okay, fair enough. Does Kaggle do any machine learning internally on its own product to gauge how Kaggle is performing?
Machine learning works best when you're at a sufficient scale, or have a sufficient scale of data to work with. And based on our current user base and use cases, if you look at it from the perspective of the number of competitions that we've run on the order of a couple hundred commercial and research competitions overall. So it's not terribly useful for that use case.
Or any other use cases for you guys, I guess?
We don't have machine learning models that are running live on Kaggle's site right now. That'll change in the next year, though.
Interesting. What kinds of models will we be implementing?
One of the types of things that we're going to be optimizing, if you go to kaggle.com/scripts right now, that's a listing of all the scripts that people have written on Kaggle, and it uses a Potness-style algorithm that's in many ways analogous to what you might see in a site like Hacker News or what you see on a site like Reddit. In the future, that's going to be one thing that we're going to be personalizing. We'll absolutely be using machine learning to personalize that as we increase the amount of content that's being created and published on Kaggle. Other things that we'll be using machine learning for in the future will include better handling spam detection or components along those lines as our forum and platform grows and becomes more popular. There's a lot of things right now where it's a low enough volume of pain there that it's the easiest and lowest friction way for us to handle that, simply automatic going through ourselves and deleting or handling the cases appropriately, but that doesn't scale out well.
Do you think of Kaggle as a social network?
Not a social network per se, but it's absolutely a community and professional network of data scientists.
Interesting. Do data scientists like fraternizing with each other about stuff that is not related to data science?
Yeah, we've heard many of our users will team up on a competition, and then they'll they'll go and meet up in person because they live close by in similar cities, or if one of them lives in Washington, D.C. and another lives in London, the user in Washington, D.C. when he's visiting London might actually stay with the person he teamed up with in Kaggle, or meet up for a meal with the person they teamed up with on Kaggle. And then we see many of our users, meetups have sprung up all around the world from users about working together to enter Kaggle competitions and talking about their performance in Kaggle competitions. So there's a Kaggle meetup in London, there's a big one in Moscow, Russia, there's one in Sydney, etc.
So I imagine there must be some employers that take part in this community to potentially recruit data scientists. What is the interaction between employers and Kaggle?
We have a couple modes of interaction with that. One of the things that we run that's a feature for communities, we have a jobs board that companies hiring data scientists post ads on saying what the positions they're hiring for. So there's a really rich set of job ads that get posted on Kaggle that our community is really active at looking at and reaching out to employers who post there, as well as for larger companies that are hiring data scientist teams instead of individual data scientists. We run recruiting competitions. We've done that with two of the biggest ones that we've run, and we do this at a regular cadence with our Facebook and Walmart.
Interesting. So I'd like to talk a little bit more about the engineering side of Kaggle. Do you clean the data sets before Kaggle competitions?
Our approach is always to put the data set up in the rawest form possible, because we believe that by putting it up in the kind of rawest, sturdiest form that we can, enables participants to make the most insights from it and really gives them the richness of the available data to work with, as opposed to kind of limiting it by establishing our own views on how it should be pre-processed and formatted, etc. So that's the overall goal. Then some cases we end up exactly on that. Other cases we need to end up pretty far from it for a couple different reasons. One of the things that will move us away from that is a lot of times the host doesn't want the precise details of the problem to be available. There's privacy implications or anonymity issues, so we'll go through and anonymize the data set or transform it so it's a anonymized feature matrix, and the participants have no idea what the underlying features relate back to. They just see a column of numbers or a column of categorical variables like A, B, C, and D.
What types of data sets are not suitable for machine learning?
You know what? That's a great question. Nothing really comes to mind that wouldn't be suitable for some sort of machine learning, potentially suitable for some sort of machine learning application. I think it's really the case of what the business goal is and whether or not machine learning is a solution for that business goal.
Okay, so data scientists will submit their different scripts, their different models to be graded. How does the grading process work?
Right now, the way that they submit things to Kaggle, they submit a CSV file that is predictions, and typically that'll be a 2-column file, one of which is an ID. That could be an ID of the image or the ID of the underlying object, and the second of which is a prediction for that. And then our system takes that, then scores it with a standard evaluation metric, and we have a lot of standard ones coded on the side, including correlation between, if it's a regression problem, between the actual results and the predictions, categorization accuracy, a probabilistic metric called logarithmic loss, etc. It scores against one of those set of standard metrics, and in some cases we'll go ahead and implement a custom metric that's very fine-tuned to the specific problem.
What's the biggest competition that's occurred on Kaggle so far, either in terms of financial size or entry size? Maybe those are the same thing.
See, one of the biggest competitions that we've had involved working with CERN, and this will be in terms of the number of participants in the competition, to given a simulated set of data in the Higgs boson to more accurately identify whether or not an event was likely a Higgs boson event in that passage. So that was an absolutely fascinating particle physics problem that attracted a wide number of participants, both from the physics community as well as the more general machine learning community.
And what were the results of that competition?
The machine learning methods that were developed on that problem specifically were more accurate or were able to more precisely identify and improve the confidence in the predictions there.
By what margin?
That's a great question. I don't know that off the top of my head.
What is a typical margin for how much Kaggle competitions can do better than, the industry solution?
That's another great question. It really varies wildly. We've seen some competitions where they'll do 300% better than the benchmark or the starting off point. So it's orders of magnitude better than where they started at. And others, it'll be 6% better. And there's a lot of the middle range where it'll be, say, 20 to 50% better. And that really depends on the details of the problem and the complexity of the underlying problem. For some types of problems that are relatively simple, you start off with a small number of features and kind of a standard approach where you have a matrix of numbers that's your training set, you're making predictions on a single target variable. Kind of that limited approach, for a lot of algorithms do really well on, kind of out of the box for that, and improvements tend to be more marginal. For more complex or richer problems, problems that involve images, problems that involve video, problems that involve free-form text data, those are the kind of real sweet spot for competitions where we see far more improvement on those. So we see more improvement on the most challenging problems in the world instead of the simpler problems in the world.
What is it about those fields that make them more conducive to that difference?
I think for each of those fields, the underlying data is so richly structured. If you think about what's in an image, you could have hundreds of different objects that are arranged in certain ways that for different scenes or different types of environments, and indoors and outdoor tend to have different properties. So it's an incredibly rich structure. Similarly, if you think of the scope and complexity of human thought that's expressed through words, it's incredibly a rich and complex domain. So simplistic models or simplistic approaches simply don't work very effectively on that. And there's so much you can do to both develop sophisticated approaches that tend to work more generally on that, as well as really fine-tuning your approach for the specific problem at hand in an individual use case. And that's an area where, for a lot of problems, humans still perform a fair bit better than automated approaches on. So there's clearly ways that you can do better, and the challenge is figuring out how to get to that gold standard to meet or beat human performance in those problems.
Has Kaggle advanced the field of machine learning as a whole?
Absolutely. There's the two key ways that we've done that are, first, providing a fair and systematic way to evaluate results and compare performance of models. So when you're competing in a Kaggle competition, you see what works and what doesn't in reality versus what's being published on or what might be severely overfit to a test set that researchers might be overfitting to by doing things like selecting the data sets that work well for their algorithm or selecting the training it with 100 different hyperparameters and only publishing the result that worked best or things like that. Kaggle competitions by their structure protect against overfitting in those forms. So the first is by providing a really clear and consistent way to evaluate performance. The second approach is by really promoting machine learning and data science to a broader audience. And the majority of many Kaggle users come to Kaggle not because they're the world experts, but because they want to learn more and develop and grow in that area. Then one thing that we've seen over the past 5 years is users who first came to Kaggle to learn a bit more about machine learning and got excited about that have then go on to do PhDs in machine learning to get hired as data scientists by the top companies and really to promote the growth of the field in that way.
How does the ethos of machine learning on Kaggle compare to the academic ethos of machine learning? Are there different techniques and is there a different culture?
Definitely. Then I think that's really a reflection of the structure and the goals. For academic machine learning, the important components are developing techniques that are new or might solve a problem that we didn't know was previously solvable and work over a longer time horizon. On Kaggle, it's really focused on specific data sets and specific problems at hand. So one of the things for as machine learning techniques develop in academia, the first time you work with you have an idea for a new technique or a new structure for a problem or domain, it's probably not going to work well. It's not going to work effectively. And it takes years and years of tough work to really optimize that and fine tune that and understand it to make it competitive with current algorithms that have many years of R&D that put into them, and people really understand how to fine tune and optimize those. So a lot of future new algorithms that might work really well 5 years out might not work effectively and win a 3-month competition because it's competing against the state of the art and fine-tuned state of the art of the other algorithms versus their early stages.
I read that data science is growing at a faster rate than any other field that is being taught in university. Does that sound accurate to you?
One of the things that I always find funny about statements like that about data science is I rarely see them backed up with data.
Yeah.
I wouldn't be surprised by any means. It's definitely our community's shown rapid growth. Definitely on the marketing angle, it's shown tremendous growth. I firmly agree with the statement that from what we've seen in the industry, maybe 1% of companies are where they should be with how they're approaching and treating data. Many companies are very, very far behind and have a long ways to go and need to hire many more data scientists and find the right people to work with. So it's definitely growing in that sense, but I've not seen a systematic comparison with every other field that's also hot and growing.
So I talked to Edwin Chin yesterday, and he said something really interesting. He thought that, actually, no, I think I asked him this, and I asked him if companies collected more data than they can make use of, and he said yes. And then I asked him, should companies hire more data scientists, or should they collect less data? And he didn't really have a concise answer for that. Do you have any opinion on that? Like, do you think companies collect more data than they need to?
I think the answer to that's going to vary by different companies, but in general, the data that's being produced by other business processes or approaches is very cheap to collect, so that it makes sense as a default or a strong default, just collect everything and don't think about fine-tuning what you're collecting. There's exceptions to that if you're in a business where the cost is exorbitant. For example, for CERN, if they collect a very, very small number of events and particle collisions are being produced because their data centers currently are in comparable sizes to some of the largest internet companies, and that's after they've divided their data sets down or subselected it by over 6 or 7 orders of magnitude. So they're forced to limit the amount of data that they could collect because of the sheer volume of it. But for most small and medium businesses and even many large companies, that simply doesn't apply. And the overall cost of data storage and data collection looks small compared to most other aspects of the business.
How do you think the cost of data collection is decreasing relative to the amount of data that is being produced? Like, do you think that the cost decrease is keeping up with the data set increase?
That, again, really depends on the business that you're in. For things that are related to the Internet of Things or collecting visual data, those can be growing at rates faster than the cost is decreasing. But for most businesses that are operating at steady state, that's not the case.
So, okay, well, like Netflix, for example, I talked to a guy from Netflix, and he said that the amount of data that they have has doubled over the last year. Do you know if storage cost has kept up with that? Like, has storage cost halved in the last year?
Storage cost definitely hasn't halved in the past. In that case, I think the point of comparison with that too isn't how much their overall data has grown, but instead what's their data per user. Is presumably their user base has grown in the past year too. Presumably they've not doubled their user base, but they've made a significant or that increasing their data is a couple of different things. They're collecting more because they have more features, and then their user base is growing. And for a lot of web companies, the amount of data that you have is a function of 2 components. The size of your user base or the number of users that you have is the obvious one. And the one that's actually not obvious is it's a function of the number of engineers that you have. Because the more engineers you have, the more features that you're building out and the more things that you could possibly be metering and tracking. So the more users means that have more grows in each database or each data set, and more engineers means more types of data, more tables, or more things that you can log and meter.
So I saw that Kaggle has a strong focus on machine learning in oil and gas exploration. Why is the energy industry such an increasingly targeted area for data science and machine learning?
Let's see. So there's actually 2 prongs to this, or 2 answers I'm going to give you. The first is that for business reasons, we're actually not currently focused on the oil and gas industry anymore at this point in time because of the collapse in the price of oil.
Oh, okay.
The price of oil moved by a factor of from over $100 a barrel towards the end of 2015 towards, kind of in February and March 2016, to below $50 a barrel. Then that had wide-reaching implications on capital allocation across the industry and what the types of things the industry was drilling on and focused on. For one specific area of the industry that machine learning has a lot of potential for is something called shale oil exploration, where producers are drilling anywhere from hundreds to thousands of wells in a small individual area. And the challenge is to figure out what the optimal drilling and what's called hydraulic fracturing or completion parameters are. And machine learning methodologies are really effective at figuring out, both predicting the ultimate productivity of a well given that underlying information, as well as working to disentangle what's actually influencing the well production there. However, capital allocation towards drilling those types of shale wells or unconventional wells has dropped off very dramatically in the current oil price environment, because those tend to be more complex and more expensive wells to drill.
Fascinating. So you have a background in biomedical and electrical engineering. How did you transition to working in data science?
That's correct. And so biomedical engineering and electrical engineering actually involve a high amount of machine learning in different aspects. A couple examples of those: for signal, on the electrical engineering side, machine learning is heavily used for signal processing and designing filters to meet certain criteria. And on the biomedical side, where we really applied that heavily is I'd spent a year optimizing EEG signals and going from an EEG signal is detected by a cap of electrodes on my head or a patient's head, to using that as a control signal to drive a motorized wheelchair or a telepresence robot, where you're not actually doing any movement whatsoever. Instead, you're only thinking about squeezing a tennis ball with your left hand or squeezing a tennis ball with your right hand, and going from that neural pattern to actually using that as a control signal to drive the wheelchair.
Can you explain how you use machine learning to convert neural patterns into control signals?
Absolutely. So the way that we did that is, first we collected a couple sets of training data for each subject, where you'd come in, you'd put a cap of electrodes on your head, then you'd spend 5 seconds thinking about squeezing a tennis ball with your left hand and picturing that, 5 seconds thinking about squeezing a tennis ball with your right hand and picturing that, and repeating that for a 20-minute couple sets of trials over a 20-minute period. Then from that, we'd take that data, we'd apply signal processing techniques to heavily filter that out and zone in on the high signal areas, then use machine learning to really figure out what the individual activation patterns for different subjects are from that data, train a system, and then the next time the subject puts the cap on, we'll apply that to predict whether or not the subject's currently thinking go left by imagining that tennis ball on the left hand, or go right by imagining that tennis ball on the right hand, and then apply that to the direction that the wheelchair is going.
So why did you end up leaving that field?
I have a lot of the goals of academia and that style of research, and I find it fascinating, but I think it's possible to have a greater impact in a commercial environment and ecosystem.
Okay, that's a very concise way of putting it.
And then it's actually one of the fascinating things about Kaggle is we've been able to run a lot of computations involving EEG and neural data as well, so we've actually been continuing to improve the state of the art in that field as well. One of the research competitions that we had that just closed involved giving a set of electrodes on your head and a patient who is doing different actions with their arm and hand, like moving their arm out, reaching for an object, grasping and squeezing that object, picking it up, setting it back down, and so on, identifying from the neural signal what the patient was doing with that object.
Interesting. So what is the future of data science?
I think there's a couple key trends at work here. First is that both the volume of data and the diversity of data that's being collected is dramatically increasing around the world. So that's going to enable a tremendous amount of new applications and intelligent applications built on top of that data, as well as mean many more data scientists and data-focused engineers are going to be hired to apply creativity and insights to leverage that data and add value with it. And then the second key trend is the software tooling, and the ecosystem around that for data science and dealing with data is dramatically improving as well. So each individual data scientist and each data science team is becoming more effective and more leveraged. The third trend is that organizations at a CEO level and executive level are becoming far more cognizant of what it means to be data-driven and what operating in a data-driven ecosystem will look like versus how they did things historically in the status quo. Data science is now a term that's being talked about by virtually every Fortune 100 CEO now, whereas 5 years ago, it was on basically none of their roadmaps. So all that's going to come into play for a couple things. The job market for data scientists is going to be incredibly hot for the foreseeable future, and we're going to get far better applications and use cases, and consumers are going to use much more intelligent products that waste far less of their time and make their lives simpler and easier to work with. And from a business standpoint, many things will become cheaper by a function of optimizing away many of the human cost involved. If you look at, say, Uber's business right now, I think over 60 to 80% is primarily going to the cost of the driver's time. So if self-driving cars or automated cars means that transportation becomes cheaper by a factor of 5 or more, or a factor of 10, that's going to be an incredible value add for society. And then that's another one of those questions too, where it's really dependent on the specific business application.
Very interesting. Is data science more of an art or a science?
One of the jokes I've heard about this is nothing that's a real science has the term science in it, applying to data science and computer science, among other things.
I have heard that.
I don't necessarily agree with that one, but I think it's a mixture of both. In the exploratory stages, there's a lot of creativity that goes into really identifying what you should be focusing on and spending your time on. And then kind of once you move past those exploratory stages, it's a very well-defined process for what tends to be effective at training a machine learning model that will work in production. And that tends to look much more like engineering than any art form.
How do you see Kaggle evolving in the future?
That's a great question. I see our community right now, as I said, it's about 350,000 data scientists continuing to grow very rapidly in the future and being one of the most core aspects of Kaggle, the core aspect of Kaggle. Then from a platform standpoint and ecosystem standpoint, I see the tools and software that Kaggle is currently creating as playing an increasing role in how data scientists are doing great analytics and work on a day-to-day basis.
What's the most bizarre data set that you've seen on Kaggle?
We have a data set that's about 400 to 500 right whales in it, and it's thousands and thousands of images of those whales. So it's effectively a facial recognition problem for whales. And looking at that data set, one thing that impressed me the most about that is looking at the kind of tops of 2 whale pictures was how on earth human biologists were able to identify this is this right whale, this is right whale number 102, and so on. One of the things when we're structuring that problem, we'd asked the data provider whether or not we could have, if there are any more pictures of right whales that we could use to increase the volume of data in the problem. And it turns out one of the surprising things about that is this is most of the right whales in the world, since it's an endangered species.
Who is the engineer that has had the most impact on your work?
See, that would be Jeff Moser, Kaggle's chief architect, who wrote the current version of Kaggle in C# from the ground up for a period of time by himself.
Ben Hamner, thanks for coming on to Software Engineering Daily and talking about Kaggle and data science and all kinds of other stuff. It's been really great having you.
Thanks a lot. It's been great being here.